is circular motion? Circular motion is a 2D motion in which a particle will move on the circular path. This circular path has certain radius r, and let's say velocity of this particle is v. So this type of motion is known as circular motion. Circular motion can be categorized in two categories. First one is uniform circular motion, and another one is non-uniform circular motion. The first one is uniform circular motion, which can be written as UCM. And another one is non-uniform circular motion. Non-uniform circular motion, which can be given by NUCM. So what is the difference between them? Could anyone tell me what is the difference between uniform circular motion and non-uniform circular motion? Anyone?
Acceleration will be different. Like acceleration can vary for non-uniform, like so.
Acceleration?
Varies in non-uniform circular motion.
Okay, and then uniform circular motion?
I'm sorry, sir.
In uniform circular motion, is there any acceleration?
It is constant.
Okay. Like, uniform circular motion is a circular motion in which speed of the particle will be constant. There will be no change in speed, but if you will look at the direction of the particle, it will be continuously in change, which means the velocity of the particle will be changing continuously. And if there is a change in velocity, definitely there will be some acceleration. So acceleration A is not zero in this case, but acceleration A will be a constant. So this type of circular motion is uniform circular motion. And if you are going to discuss about non-uniform circular motion, then we can say that in this type of circular motion, speed may change or speed may vary from point to point. Direction will definitely change, no doubt about it. So velocity will also change. And again, in this case, acceleration A will not be zero. But interesting point is acceleration will not be constant in this case. Acceleration will change. So in uniform circular motion, we have variable acceleration working on the particle. And in uniform circular motion, we have constant acceleration working on the particle. In uniform circular motion, if you will look at the particle at different points of the circle, speed will be same throughout the motion. So if I have a circular path, and let me mention here point P, point Q, point R, point F, point whatever. So at all points or at any point between P and Q, the speed will be same. Velocity will change, but it will change in direction. There will be no change in magnitude of the velocity. Hence, there will be a constant acceleration in this case. But in non-uniform circular motion, if velocity at point P is with certain magnitude, then the velocity at point Q will be with different magnitude of velocity. Direction is definitely changing. So these two types of circular motion can be dealt with certain parameters. And these parameters will be given as, let's say this is a circle, and for reference we will take x-axis and y-axis. Let's say this is 0, 0 or center of the circle. And there is a particle which starts moving from this point P. The particle was at point P at time t equals to 0. And after certain time interval, the particle is at point Q. So in this time interval, let's say this time interval is delta t, some of the angular displacement has been traveled, and this angular displacement is given by theta. This is radius r of the circle, and let's say this will be arc length pq. So first relation to deal with circular motion is angle. In mathematics, we call it angle, but in physics, in circular motion, we will call it angular displacement. Angular displacement. And angular displacement will be given by theta is equals to arc length divided by radius of the circular path. So this will be theta is equals to, let's say this arc length is x unit. So this will be x by r. Understood? And if let's say you take it as particle goes from point Q to point R, in that case, this will be some different angle. Let's say this angle is theta 1 in this case, or let me call it as theta 0. And this complete angle is, let's say, theta. So what will be angular displacement if particle move from point Q to point R? So in this case, angular displacement can be given as delta theta. And this will be theta final minus theta initial. According to the condition, theta final is theta and theta initial is theta 0. And again, you can write it as delta theta. Displacement, it will be final theta minus initial theta, which means it will be arc length of final position divided by r minus arc length initial position divided by r, which means delta theta can be given as x final minus x initial divided by r, which will be nothing but delta xy. So delta theta is delta xy r. What do you think? What will be its SI unit? SI unit of angle theta or angular displacement. What will be its SI unit? Yes, anyone? Anyone? SI unit of angle?
Theta or omega?
Radian. SI unit of angle or angular displacement will be radian. What do you think about its dimension? Dimension. What will be the dimension? Since theta is arc length divided by radius. Arc length is a length. Radius is also a length. Length by length will cancel out. So there is no dimension of angle or angular displacement. So it will be dimensionless. We can write it as M0, L0, T0, or in some book we write it as 1. So angular displacement or angle theta is an example of a physical quantity which is dimensionless but has a unit. Any doubt in it? Okay, now let's say this particle at point P or point Q or point R is moving with a constant speed, and that constant speed is given by V. This constant speed V is a linear speed. It is not angular speed. So we will find out angular speed of the particle and we will relate it with linear speed. So second point is angular velocity, whose magnitude will be same as angular speed. Why is it so? Because in uniform circular motion, there is no change in magnitude of the velocity. So magnitude of angular velocity will be same as angular speed, and this will be displacement or angular distance divided by time taken. Yes, delta theta by delta t. If you are finding average, this will be delta theta by delta t. And if you are interested in instantaneous, this will be d theta by dt. What do you think? What will be the SI unit? SI unit of angular speed or angular velocity?
Radian per second.
It will be radian per second. Radian per second. Sometimes we write it as RPS. Yes. What will be its dimension? Yes, what will be its dimension? Again, theta is dimensionless, so we are left with time, and accordingly dimension will be t minus. Understood? Next point we will try to understand is angular acceleration. Angular acceleration given by alpha. So if you are looking for average, this will be alpha bar. Change in angular velocity upon time. And if you are looking for instantaneous, this will be alpha dw by dt. Same is here, d theta by dt. So what will be its SI unit? Yes, its SI unit will be what this time? This will be radian per second, which means radian second raised to minus 2. And if you are interested in dimension, dimension will be t minus 1. Am I right? Am I right or any doubt in it?
No, sir.
Yes. Okay, next point is relation between linear parameters relation between linear parameters and angular parameters of a circular motion. So linear parameters of a circular motion or linear parameters for the particle on a circular path will be linear distance or displacement, which could be given as S. In some book we write it as S, and in some book we write it as X. Linear speed or velocity will be given as V. Linear acceleration will be given as A. Opposite to it, we have angular distance or displacement, which will be given by theta. Angular speed or velocity will be given by omega. Angular acceleration given by alpha. Then we have linear momentum given by P. Then we have angular momentum, which is given by L. So there is a simple relation between linear parameter and angular parameter. And the relation is angular In case of momentum, there will be something different. Apart from momentum, all the parameters are connected with angular parameters by a simple factor r. R is the radius of circular path. So linear parameter is equals to r times angular parameter. For example, if you want to find out linear distance or linear displacement x, this will be r into angular displacement. So linear parameter x is equals to r into theta. If you will take derivative on both sides, this will be dx by dt. There is no change in radius with respect to time, but angle theta is continuously changing. So this will be d theta by dt. Dx by dt, linear distance by time, linear speed, r into angular distance by time, omega. So first relation is x equals to r theta. Second one is v equals to r omega. If you will again differentiate it with respect to time, you will have r d omega by dt, which will be linear acceleration equals to r into angular acceleration alpha. Its vector form is given as omega cross r. Its vector form is given as alpha cross r. And if you want to find out the direction of A or R, direction of omega or alpha, it is given by right hand thumb rule. Right hand thumb rule. Interesting point is angular parameter and linear parameter has somewhat different relation. It is not the same as we have linear parameter equals to r into angular parameter. In this case, it is slightly different. So angular momentum is given by r factor into linear momentum. And we write it as angular momentum L is equals to r cross p, or in special case, angular momentum L is also given as r into p mv, that is mvr. This is also a formula for angular momentum, sorry, but angular momentum will be in special case if it is angular momentum L is equals to mvr. Any doubt in it? Yes, any doubt? Question is find the angular velocity of, I should write it as angular speed of r and minute hand and second hand of a clock. Yes, motion of clock or the hands of clock are uniform circular motion, and we have to find out angular speed of r and minute hand and second hand. So first of all, what is the concept for angular speed? Angular speed is total displacement theta divided by time taken t. This will be omega. So if you are going for Rn, omega will be what? For Rn, if you will take a complete cycle, angle will be 2 pi. and how much time it will take to complete 360-degree or 2 pi angle. So R end will take 12 hours to complete one cycle. So time period will be 12 hours. If you will divide it by 2, this will be pi by 6 and unit will be radian per second. For minute hand, again, in one complete cycle, angular displacement or angular distance will be 2 pi divided by time taken. So how much time does a minute hand take to complete one cycle? So minute hand complete one cycle in 1 hour. So this will be 1 hour. Answer will be 2 pi. Radian per hour. Again, this unit is wrong. It will be radian per hour because time is in hours. Next we have, or you can also write it as 2 pi divided by 60 minutes. It will be pi by 30 radian per minute. And again, minute can be converted into seconds also. For second hand, omega will be 2 pi divided by time taken to complete one cycle by a second hand. So it takes how much time to complete one revolution? If it is second hand, 1 minute. So this will be 2 pi radian per minute. And if we convert it into seconds, 1 minute is 60 seconds. So this will be pi by 30 radian per second. Understood or any doubt? Yes?
No, sir.
Okay, next point is for a particle to be on circular path, there is always need of a force because velocity is continuously changing in direction without changing its magnitude, which implies that there will be some acceleration A. If there is some acceleration A, there has to be a force. Without force, no system can have an acceleration. So acceleration implies that there will be a force, and this force which is necessary, which is required for a particle to be on circular path is known as centripetal force. So we have here centripetal force Fc, which is given by m into A. This time A is centripetal acceleration. Centripetal acceleration means acceleration which is working towards center, or sometimes we call it center seeking acceleration because the word centripetal means center seeking or towards center. Magnitude of this acceleration, centripetal acceleration, is v square by. So formula for centripetal force will be m v square by r. It will be m v square by r. Since there is a relation between v and omega, which is connected as v equals to r omega, fc can also be given as m by r into r omega square, which will be m r square omega square by r. One of the r factor will cancel out, and hence centripetal force will be m r omega square. So we have two formats for centripetal force. One is m v square by r. In this case, m is the mass of the particle moving on circular path, r is the radius of circular path, and v is linear speed. Remember, v is not angular, v is linear speed of the particle. So centripetal force is mv square by r, and if you are not given with linear speed, you are given with angular parameter, then it will work as mr omega square. Any doubt in it? Let's say we have a stone of mass 0.5 kg is moving on a circular path with constant speed of 10 meter per second. Find the centripetal acceleration of the stone if radius of circular path is 0.1 meter. So this is straightforward question. Mass of the stone is 0.5 kg. We are given with constant speed v 10 meter per second and radius of the circular path is 0.1 meter, and we have to find out using this information centripetal acceleration. Centripetal acceleration AC is given by v square divided by r. So centripetal acceleration will be AC is equals to v square, that is 10 into 10 divided by r, that is 0.1. If you will arrange it, this will be point will be eliminated by a factor 10. So this will be 1000. And if you are interested in centripetal force, this will be mass times centripetal acceleration. Mass is 0.5 kg and centripetal acceleration is 1000. So centripetal force working on the stone will be 500 Newton. Understood or any doubt? Yes, any doubt? In chemistry, we were studying states of matter, and in states of matter, all the laws have been discussed: Bayes' law, Charles' law, Gay-Lussac's law, Avogadro's law. So now we will solve some questions on these laws. Question first is, what will be the pressure of a gas in 2-liter container at constant temperature if volume is doubled? So in this question we have constant temperature. One of the core concept for gas to deal with is PV equals to nRT. Now we have a certain amount of gas filled in a container with volume 2 liter. So n factor is constant, R is always constant, and T is given constant in the question. So if all these three factors are constant, it means PV will be a constant value. And if PV is equals to constant, this is known as Boyle's law, which implies that P1 V1 will be equals to P2 V2. Let's say initial pressure of the gas is P, initial volume is 2. We have to find out the new pressure P2. If the volume is doubled means this will be 4 times. So 2 to the 4. So pressure in second case will be half of original pressure of the gas. Another way to say the same thing is PV is equals to constant means P is directly proportional 1 upon V, which means they are inversely connected. So if you are increasing volume by factor 2, according to the proportionality, pressure will be decreased by a factor of 1 by 2, which means P new will be half of the original pressure of the gas in the container. Understood? Any doubt in it? Yes.
No, sir.
Next question is, find volume of a gas at temperature 23 degrees Celsius if its volume at 12 degrees Celsius is 3 liter. Consider pressure of the gas to be constant. So what will be the relation in this case? Again, we can use PV equals to nRT. Amount of gas is fixed, R is fixed, but this time P is fixed, constant. So if you will look at PV equals to nRT, R factor is not changing, N factor is not changing, and this time P is also not changing. So we have V directly proportional T. V directly proportional T means V1 by T1 is equals to V2 by T2. So V1 is 3 liter and T1 is 12 degrees Celsius. Remember, if the temperature in degrees Celsius, you have to convert it into Kelvin. Because in equation, ideal gas equation, PV equals to nRT, T is in Kelvins. So you have to convert it into Kelvin. So this will be 12 plus 273. You have to find out volume V in second case when the temperature is 23 degrees Celsius. So this will be 23 plus 273 because temperature has to be in Kelvin. And now if you will arrange it, this will be V equals to 3 into 273 plus 23 will be 300, I think. Divided by 12 plus 273 will be how much? This will be 285. And if you will solve it, you will get how much? 3 into 300 divided by 285. Simplify it. It will be approximate 3.15 liter. Understood or any doubt? Yes, any doubt in it?
No, sir.
Next question is, find the volume of a gas at 1 atm pressure, 23 degrees Celsius, if amount of gas is 2 moles. Yes. So how will you solve it? In this case, we have pressure 1 atm and 2 moles, temperature 23 degrees Celsius plus 273 will be 300 Kelvin, and we are interested in V. So we can use ideal gas equation PV equals to nRT, and V will be given as nRT divided by P. When you will apply this formula V equals to nRT divided by P, you have to be careful about the value of R, universal gas constant. Universal gas constant can have different values. It will all depend on the units of other parameters. So for example, in this case, N is 2, temperature is 300, pressure is in ATM, which is 1 ATM. So the value of R in this case will be 8.314. Now you can solve it, and you will get the volume in centimeter cube. Solve it. This will be 600 into 8.314. V will be how much? Yes, how much? 4988.4. Any doubt? Yes, any doubt? Some important conversions, you have to learn them. First one is 1 liter is 1000 ml, which will be 1000 centimeter cube, which is same as 1 dm cube. Then we have 1 meter cube, which is 10 raised to power 3 dm cube, which will be 10 raised to power 3 liter, because 1 dm cube is 1 liter. And you can also write it as 10 raised to power 3 dm cube will be 10 raised to power 6 centimeter cube. And centimeter cube is ml, so this will be 10 raised to power 6 ml. Another one is pressure. 1 atm is 76 centimeter of Hg, which is 760 mmHg, which is given as 760 torr, which implies that 1 mmHg is 1 torr. 1 atm is 101.325 kilopascal, which means 101.325 pascal. Or you can write it as 1.01 into 10 raised to power 1, 2, 3, 4, and 5 pascal. 1 pascal is Newton per meter square. And then we have a relation 1 bar. 1 bar is 10 raised to power 5 pascal. So if we have 1 atm, which will be equals to 1.01 into 10 raised to power 5 pascals. And since 10 raised to power 5 pascal is 1 bar, so this will be 1.01 bar. Understood? You have to learn, you have to remember these facts or parameters. Now we have value of R. So value of R will depend on the units of other parameter. For example, it will depend on volume, then pressure, then temperature. Pick the value of R. First one, if volume is in liters, pressure is in atm, and temperature is in Kelvin. In that case, R will be 0.0821 liter atm mole inverse Kelvin inverse. Next is volume is in liter, pressure is in bar, and temperature in Kelvin. This will be 0.083 liter bar mole inverse Kelvin inverse. It is almost same. If you will look at relation between atm and bar, this will be approximate same. 1 bar will be approximate 1 atm, because 1 atm is 1.01 0.01 bar. So there will be a very less difference between the value of R for pressure in ATM and pressure in bar. Next one is if volume is in meter cube and pressure is in Pascal, that is Newton per meter square, and temperature is still in Kelvin. In that case, R will be 8.314 joule Kelvin inverse mole inverse. Next is we have volume in centimeter cube. Volume in centimeter cube, and this will be Newton per centimeter square. Temperature is in Kelvin. In that case, this will be 8.314 into 10 raised to power 7 Earth Kelvin inverse mole inverse. This can be connected from here also. Because if you will convert joule into Earth, this will be 10 raised to power 7 Earth. The last one is, which is 1.987 approximate to calorie Kelvin inverse mole inverse. In this case, joule will be converted into calories. Understood or any doubt? Yes, any doubt? Okay. Next point is Dalton's law of partial pressure. Dalton's law of partial pressure. Dalton's law of partial pressure states that total partial pressure on the wall of a container will be equal to the sum of pressure given by individual gases. I is 1 to n, which means we have a container in which we have n different gases. These gases do not chemically react with each other, which means these gases are not chemically bonded with any other gas. They are inactive. In that case, overall pressure on the walls of the container will be equal to the sum of individual partial pressure given by different gases in the mixture. And if you want to find out partial pressure of any gas, partial pressure of any gas will be mole fraction of that gas multiply total pressure of the container. So partial pressure for second gas will be mole fraction of the second gas into total pressure of the container. This is Dalton's law of partial pressure. Next we have Graham's law of diffusion. Graham's law of diffusion states that what will be the rate of diffusion of a gas if gas is coming out of a leakage or a hole. So Graham's law of diffusion is very simple, which states that rate of diffusion of a gas from a leakage or a hole is inversely related with square root of density of the gas. Greater will be the density, less will be rate of diffusion. Smaller the density, greater will be rate of diffusion. This implies that gases with low density can diffuse faster. Diffuse faster means gases with low density will come fast out of a leakage or a hole. This can also be stated as R1 by R2 is equals to square root of D2 by D1, which will be equivalent to molar mass of second gas by molar mass of first gas. So this concept in terms of molar mass will be far more easier to understand. This will be R inversely related with the square root of the molar mass, which clearly indicates that greater the mass of the gas, less will be its rate of diffusion. So if I have hydrogen gas and I have helium, molar mass of helium is greater than molar mass of hydrogen, and both of these gases are filled in a container. There is a hole in the container. Then which gas will come fast out of that hole, and in other words, which gas will leave the container first? Since molar mass of the hydrogen is less than molar mass of helium, so according to Graham's law of diffusion, the rate of diffusion of hydrogen gas will be faster than helium, which means hydrogen will come out of the container at a faster rate, which implies that hydrogen gas will leave the container first. Are you getting it? Yes. Yes. Any doubt? Okay.
No, sir.
Okay. Along with the term diffusion, there is another term which is diffusion, and there is no big difference between them. Diffusion and diffusion basically is the rate of flow of gaseous particles in a specific direction, and the main difference in effusion and diffusion is that effusion is proceeded deliberately. You have to apply some pressure, and due to that pressure there will be a flow of the gaseous particles. That is known as effusion. Understood or any doubt? So let's say we have three different gases into the same container. We have oxygen gas, we have nitrogen gas, chlorine gas, we have CO2 gas. Question is, what will be the order of rate of diffusion? So to understand the rate of diffusion, you first of all have to calculate their molar mass. So molar masses of the gas is capital M. Molar mass of oxygen is, yes, molar mass of oxygen 32. Molar mass of nitrogen 28. Molar mass of chlorine 71 will be. Molar mass of CO2 44. So rate of diffusion is connected with square root of molar mass. So which gas will have the fastest rate of diffusion? Rate of diffusion will be greater for the gas which has least molar mass, and in this case it is nitrogen. So rate of diffusion of nitrogen will be greater or greatest or maximum possible than oxygen, then CO2, and then finally Cl. Understood or any doubt? Yes? No doubt? Okay. Last point is velocities of gas molecule. Velocities of gas molecules. First one is most probable speed. Most probable velocity. This will be equals to V most probable square root of 2RT by M. Then we have average velocity. Average velocity, which is given by VR. This will be square root of 8RT upon pi M. Next we have root mean square velocity. root mean square velocity, which is given as VRMS, which is root 3RT by M. So these are three different types of velocities a gaseous molecule can have: most probable, average, and root mean square. Understood or any doubt? Yes? Okay. States of matter is completed. Okay. Do you know what are critical constants? Critical temperature, critical pressure, critical volume. Yes. Critical temperature is the maximum possible temperature below which the gas can be easily liquefied. In other words, critical temperature is the temperature above which no gas can be liquefied. Doesn't matter how much pressure you are going to apply on it. And every gas has its critical temperature. Corresponding to critical temperature, we have certain pressure and volume. Pressure is known as critical pressure and volume is known as critical volume. Question is, क्वेश्चन इस पे काफी ज्यादा दे नहीं रखे इसने, एक दो ही क्वेश्चन. सॉल्यूशन 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 बताऊंगा क्या करूं मैं इसका. Find the ratio of rate of diffusion, hydrogen gas and oxygen gas. So this is very easy to solve. Rate of diffusion of hydrogen gas over rate of diffusion of oxygen gas will be square root of molar mass of oxygen gas divided by molar mass of hydrogen gas. This will be square root of, what is the molar mass of oxygen? 32. And molar mass of hydrogen is 2. This will be how much? 16. So rate of diffusion of hydrogen divided by rate of diffusion of oxygen is square root 16, that will be 4. Which means rate of diffusion of hydrogen to the rate of diffusion of oxygen will be 4 by 1. Or in other words, rate of diffusion of hydrogen gas is 4 times greater than rate of diffusion of oxygen, which again implies that hydrogen gas will leave the container first. Yes, or any doubt? नेक्स्ट पॉइंट इज, अब क्या हुआ, मैथ्स ना, मैथ्स में क्या पढ़ा था भाई लास्ट टॉपिक हमने? फंक्शन, डोमेन रेंज करा दिया था ना? ओके, नेक्स्ट कॉन्सेप्ट इज कॉम्प्लेक्स नंबर. Complex number. Complex number is a number of the form z is equals to a plus iota b. This is complex number. In any complex number, we have two parts. First one is real part of the complex number, which will be written as real part complex number z. This is the part of the complex number which is without iota, that is a. Then we have imaginary part of a complex number, which is given by imaginary part z of complex number. This will be component with iota b. And in this case, we have a special quantity, that is iota, which is square root of -1. So any number of the form a plus iota b is known as complex number. In a complex number, we have real part and imaginary part. And interesting point is these parts, whether it is real or imaginary, both have to be real numbers. So real part of a complex number is real number, and imaginary part of a complex number is also a real number. But their combination of real part and imaginary part is complex number. Before dealing with complex number, let's discuss some concepts regarding iota. Iota is known as imaginary quantity or imaginary number given by root of -1. On squaring both sides, you will get -1. If you will do it power 3, this will be iota square into iota. Iota square is -1, so this will be equivalent to minus iota, and iota raised to power 4 will be 1. In this case, iota raised to power 4 is known as magic power of iota. Magic power of iota. Why is it so? Because all the calculations of power of iota will be done in the form of power 4. So there will be a question in the format of iota raised to power certain power m. We have to convert this power m into the form of power 4. So m can be written as 4n plus k. 4n plus k will be obtained by dividing m with 4. If you will divide quantity m by 4, let's say you take n times table and there will be some quantity. Let's say this quantity is p, and on subtracting we get k. So m can be written as divisor into quotient plus remainder. So m will be 4n plus k. And if you will split it, it will be iota raised to power 4 raised to power n into iota raised to power k. Iota raised to power 4 is 1 and 1 raised to power n will be 1. So we are left with iota raised to power k. So to get the answer of any power of iota, you have to check what is the remainder. What is the remainder when you divide that particular power with 4? There are three different cases. If k is 0, if k is 1, if k is 2, and if k is 3. If k is 4, again you will have the same case. In case of k equals to 0 or k equals to 4, answer will be 1. In case of k equals to 1, answer will be iota. In case of k equals to 2, answer will be -1. And in case of k equals to 3, answer will be minus iota. Let's say we have iota raised to power 2025. You have to simplify it. So to simplify, what you have to do is that just divide this number by 4 and check for the remainder. We are not interested in the quotient. We are interested in remainder. So if you will divide it 4, you will get 4 5 is 20 and 4 6 is 24. So you will left with iota with remainder 1. And hence answer will be iota. Let's say I have iota raised to power 3001. If you will divide it by 4, what will you get as remainder? How? 3000 is divisible by 4. Yes, now. 4 7 is 28. You will have 2. Then you will take 0. 4 5 is 20. Completely divided. So we are left with 1. Will be. Understood? Understood? Yes or no? If I have 13 or let's say I have 14 this time, we are left with 2 power. 14 is 12, 2 power. Iota power 2 is minus. This is the method to solve any power of iota. Divide it by 4 and look for the remainder. Next point is operations on complex number. Which will be addition, subtraction, multiplication, division, and equality of two complex numbers. In complex number, we do not deal with inequalities. Inequalities are dealt in real numbers, but in complex number, there will be no concept of inequality. So let's say first one is equality of two complex numbers. I have Z1 complex number x1 plus iota y1, another complex number z2, x2 plus iota y2. And if I have complex number z1 equals to complex number z2, this is possible if and only if imaginary part, this is possible if and only if real part of complex number z1 is same as real part of complex number z2, which means x1 has to be equals to x2, and imaginary part of z1 will be equals to imaginary part of z2, which implies that y1 has to be equals to y2. This is first condition. This is second condition. Both the conditions has to be satisfied. Let's say I have x plus 1 plus y minus 2 iota, and this is equals to a complex number which is, let's say, 5 plus 3 iota. Find the value of x and y. Find the value of x and y. Hello. lecture में दे दो. So how will you find out x and y? If these two numbers are equal, then their real part will be equal and their imaginary part will be equal. So x plus 1 is equals to 5, which will give us x equals to 4, and y minus 2 is equals to 3, which will give us 5. This is the concept of equality of two complex numbers. Next, if you want to add two complex number, how to add them? So let's say we have two complex numbers z1 x1 plus iota y1, and another complex number z2 is x2 plus iota y2. If you want to add them on addition, real part gets added with real part and imaginary part will be added with imaginary part. So answer will be x1 plus x2 plus iota y1 plus y2. There are some interesting properties of addition of two complex number. One of them is commutative. Addition of two complex number is commutative, which means z1 plus z2 will be same as z2 plus z1. In other words, it doesn't matter which of the complex number is taken first and which is last. The addition will be same. Or you can add any two complex number in any order. There are no restrictions on addition according to order. Second property is associative. Addition of two complex number is associative, which implies that if you have three complex number, you can add them in any order. Either you can write it as z1 plus in bracket z2 plus z3, which will be same as z1 plus z2 in bracket plus z3. Then we have additive identity. For the addition of two complex numbers, additive identity is a complex number which will be added to a complex number to get the same number again. Which means if I have a number 1, which element I will add to number 1 to get 1 again? It will be 0. Similarly, for any complex number, 0 complex number is a complex number which will behave as additive identity. If you will add 0 complex number in any complex number, you will get that complex number back. Next, we have additive inverse. Additive inverse of a complex number is a complex number which on adding with the original number will give us 0 complex number. So I have a complex number z and I add 0 complex number to it, I will get z back. This is additive identity. If I have complex number z and I add it with minus z, I will get 0. This is additive inverse. Question is, if you have two complex number z1, 3 minus 2 iota, z2 minus 4 plus 5 iota, you have to find first part z1 plus z2, second part additive identity of complex number z1 as well as z2, and third one is additive inverse of complex number z1 and z2. So if z1 is 3 minus 2 iota and z2 is minus 4 plus 5 iota, what will be their addition? It will be z1 plus z2. Real part will be added with real part of the complex numbers and imaginary part will be added with imaginary part of the complex numbers. So if you will arrange them, this will give minus 1 and this will give plus 3 iota. If you are looking for additive identity, of complex number z1, it will be 0 complex number, 0 plus 0 iota, simply you can write it as 0. Additive identity of z2 will be 0 plus iota 0, that is 0 complex number. This is first part. This is second part. Now we are on third part. Third part is additive inverse. Additive inverse of complex number z1, it will be minus of z1. So this will be minus 3 plus 2 iota. And if you are looking for additive inverse of complex number z2, it will be minus z2. So the answer will be in this case 4 minus 5 iota. Understood or any doubt? Yes, any doubt? सो गए क्या आप लोग? हाँ ना कुछ तो बोल दो.
No doubt, sir.
Next one is, which is multiplication of a scalar with a complex number. Multiplication of a scalar with a complex number. Here scalar means any real number, constant value, and let's say complex number z is x plus iota y. So if scalar is k and k may be any real number, what will be k times z? So this will be k times x plus iota y. The point is, if you want to multiply scalar with a complex number, you have to multiply it in both the parts of the complex number, in real part as well as in imaginary part. So you will have kx plus iota ky. Let's say I have a complex number 3 plus 2 iota, and according to this complex number z, you have to find out minus z, 2z, 1 by 2z, minus 2z. So if z is 3 plus 2 iota, what will be minus z? Minus z means minus 1 times complex number. It will give us minus 3 minus 2 iota. What will be 2z? 2z means twice multiplied with this number. This will be 6 plus 4 iota. 1 by 2z, 1 by 2z is 1 by 2 times 3 plus 2 iota, which will give us 3 by 2 plus iota. Finally, we are left with minus 2z. This is minus 2 multiplied with 3 plus 2 iota, which will be minus 6 minus 4 iota. Understood? Yes, understood. Any doubt?
No doubt, sir.
Okay. Now we can discuss subtraction of two complex number. Subtraction is a special case of addition. Special case of addition, which means if you have complex number z1, x1 plus iota y1, and complex number z2, x2 plus iota y2, you want to have z1 minus z2, it can also be written as z1 plus of minus z2. And in this case, the concept is simple. You have to subtract real part with real part and imaginary part with imaginary part. But you have to be careful about the order. In case of subtraction, you cannot subtract any number from any number, which means while selecting the real part and imaginary part, you have to be careful about the order of complex number z1 and z2. So if it is z1 minus z2, then you have to subtract real part of z2 from real part of z1 and imaginary part of z2 from imaginary part of z1. So according to this, this will be x1 minus x2 plus iota y1 minus y2. Let's take an example. Complex number z1 is minus 3 plus 2 iota, and complex number z2 is minus 1 minus iota. We have to find out z1 minus z2. So z1 minus z2 will be minus 3 plus 2 iota minus 1 minus iota. If you will open the bracket, this will be minus 3 plus 2 iota, and minus gets multiplied into the bracket, will change the sign, will be plus 1 plus iota. Minus 3 plus 1 is minus 2 plus 2 iota plus iota is 3 iota. Now if you are interested in z2 minus z1, this will be minus 1 minus iota minus 3 plus 2 iota. And if you will again open the bracket, this will be minus 1 minus iota. Minus gets multiplied into the bracket, will change the sign of component. So this will be plus 3 minus 2 iota. And finally we will have -1 plus 3, that is 2, and -1 iota minus 2 iota minus 3 iota. Interesting point is, in the subtraction case of two complex number, Z1 minus Z2 is not equals to Z2 minus Z1. In fact, Z1 minus Z2 can be written as minus times of Z2 minus Z1. Understood?
Yes, sir.
Next point is multiplication of two complex number. Multiplication of two complex numbers. Let's say complex number Z1 is x1 plus iota y1. Complex number Z2 is x2 plus iota y2. You have to multiply them. So Z1 multiplied with Z2. Multiplication is done in a simple way as we do it in algebra. X2 plus iota y2. We will take first element or first part of the first bracket and multiply it with all the parts of the second bracket. So x1 multiplied with x2 will be x1 x2. X1 multiplied with iota y2 will be iota x1 y2. Similarly, we will take iota y1, which will give us iota x2 y1 plus iota square y1 y2. And if you will rearrange it, it will be x1 x2 minus y1 y2, because iota square is -1 plus iota outside x1 y2 plus x2 y1. The simple concept is you just multiply real part of complex number z1 with other parts of complex number z2, and in the final step you just have to separate them, real parts together and imaginary parts together. Understood? Similar to addition of two complex number, multiplication of two complex number also have certain properties. First one of them is commutative. Z1 into Z2 will be same as Z2 into Z1, which again implies that it doesn't matter in which order you are going to multiply two complex number, the answer will be same. Since multiplication of two complex number is commutative, it will also be associative, which means you can multiply three complex number in any order. You can multiply it as Z1 multiplied with Z2, then multiplied with Z3, or you can multiply it as Z1 multiplied with the multiplication of Z2 and Z3. Now we have multiplicative identity, same as we have additive identity. Multiplicative identity is a complex number which will multiply with a complex number to get the same complex number. And in this case, that will be 1. If you have any complex number z and you are going to multiply it with complex number 1 plus 0 iota, that is 1, answer will be the original complex number z. So 1 is going to be multiplicative identity for all the complex number. Next we have multiplicative inverse, same as additive inverse, and multiplicative inverse will be a complex number which multiplied with a complex number will give 1. So if I have a complex number z, and I multiplied it with a specific number to get 1, then obviously this has to be 1 by z. In this case, 1 by z is known as multiplicative inverse. So I will write it as multiplicative inverse. Multiplicative inverse of any complex number z will be given by 1 by z, which is written as z inverse equals to 1 by z. And multiplicative identity of a complex number, multiplicative identity of a complex number z will be given as z times a complex number which will give us back z, and it will be 1 plus 0 iota. So multiplicative identity will be 1. Any doubt in it? Okay. Now we can work on division of two complex number. Division of two complex numbers. So let's say we have complex number z1, which is x1 plus iota y1, and then we have complex number z2, which is x2 plus iota y2, and I want to find out z1 by z2. So z1 by z2 will be given as x1 plus iota y1 divided by x2 plus iota y2. To simplify this expression, or to simplify the division of two complex number, what you have to do is you have to multiply by changing the sign of iota in denominator. So you have to multiply it with x2 minus iota y2 divided by x2 minus iota y2. Remember, you have to change the sign of iota part only, right? You will not change the sign of real part. Sign will be changed only of imaginary part. And if you will adjust it, it will be x1 plus iota y1 multiplied with x2 minus iota y2. In denominator, it will be like a plus b into a minus b, which gives us a square minus b square. If you will simplify it, this will be x1 x2 minus iota times x1 y2 plus iota times x2 y1 minus iota square y1 y2 divided by x2 square. Iota square is minus 1. So minus 1 with minus will give it in plus, and this will be y2 square. In numerator, real part has to be together and imaginary part has to be together. Again, iota square is minus 1. So this minus with minus will be plus. So this will be x1, x2 plus y1, y2. Take iota outside, it will be x2, y1 minus x1, y2 divided by x2 square plus y2 square. In this complete process, you have studied an important property of identity. If we have a plus b into a minus b in simple real numbers, it is always a square minus b square. But if you have the same concept in iota, a plus iota b into a minus iota b, it has to be minus. It has to be minus, but due to iota square, this minus will be converted into plus sign. Are you getting it?
Yes, sir.
Okay, let's say I have complex number, very simple complex number 1 plus iota, another simple complex number 1 minus iota, and I want to find out z1 by z. So I will write it as 1 plus iota over 1 minus iota. To simplify it, we will multiply it with 1 plus iota upon 1 plus iota. In numerator, you will have 1 plus iota to the whole square. In denominator, it is going to be a square plus b square, which will give you 2. And if you simplify the identity in the numerator, this will be a plus b whole square, which will give us a square plus b square plus 2ab divided by 2. Since iota square is minus 1, so plus 1 minus 1 will cancel out. So we will have 2 iota by 2. Answer will be iota. Understood? Again, in complex number, there are certain complex number which are frequently used. You have to remember they are square. For example, 1 plus iota to the whole square will be directly 2 iota. You have to remember it. And 1 minus iota to the whole square will be what? Minus 2 iota. Next, if you are having 1 by iota, this will be what? 1 by iota is 1 by iota is iota by iota, which means iota by iota square, which means this will be minus iota. If you are having 1 upon iota square, 1 upon iota square will be what? 1 upon iota square is minus 1, so this will be minus 1. If you are having 1 upon iota cube, this will be what? 1 by iota or minus iota. This will be minus iota. Since 1 upon iota is minus iota, so 1 upon minus iota will be plus iota. Understood? One more point. If you are having iota powers in AP, for example, I have A plus B plus C plus D. There are 4 terms with certain powers of iota, and these powers in AP, A, B, C, and D are in AP. In that case, answer will be 0. So you just have to check whether the powers of the given 4 terms of iota are in AP or not. If it's in AP, answer will be 0. You need not to solve it. For example, if I ask you what will be the answer, iota raised to power 2000 plus iota raised to power 2001 plus iota raised to power 2002 plus iota raised to power 2003. So there are 4 terms, and in each term the power of the iota is in AP. So answer directly will be 0. It may be AP with any difference. Maybe with common difference 1, maybe with common difference 2, maybe with common difference in fraction, maybe with common difference in, sorry, it should not be in fraction, but it may be in negative. Understood or any doubt? Yes. Any doubt? No doubt. Okay. Now we can discuss about conjugate of a complex number. Conjugate of a complex number. If we have z as a complex number x plus iota y, then conjugate of complex number z, conjugate of complex number z is given by z conjugate. Z conjugate is x plus iota y conjugate, and when you will apply conjugate to a complex number, sign of the imaginary part will flip. Remember, sign of the imaginary part will flip. There will be no change in the sign of real part. So it will be x minus iota y, which means if I have complex number z and here we have z conjugate, tell me the answer. What will be conjugate of 1 plus iota? Yes, 1 minus iota. If I have 1 minus iota, it will be 1 plus iota. If I have minus 1 minus iota, it will be minus 1 plus iota. Remember, sign will be changed only of imaginary part. If we have minus 1 plus iota, this will be minus 1 minus iota. If I have iota, this will be minus iota. If I have minus iota, this will be plus iota. If I have 3, this will be 3. Because there is no imaginary part in 3. If I have minus 3, this will be minus 3. So this is the concept of conjugate of a complex number. When you are going to take conjugate of a complex number, you just have to change the sign of its imaginary part. Are you getting it? Yes or no? हम सब भी कर सकते हैं आप लोग, अगर बोलने में प्रॉब्लम है तो. There are only few students who are responding. पता नहीं आप लोगों के पास इतना पैसा कहाँ से है. पैसा देते हैं, पढ़ाई भी नहीं करते. ए ना तो पढ़ाई करना चुपचाप से. सैटरडे है तो वरुण धवन बनोगे तुम यहाँ. Okay, next point is next point. Let's say we are going to discuss about mode of a complex number. Mode of a complex number. That is modulus of a complex number. Mode means modulus. Let me write it to modulus. Otherwise, आप इसे mode समझ लेंगे. Modulus of a complex number. So if we have complex number z as x plus iota y, x plus iota y, then its mode or modulus of complex number z can be written as modulus of x plus iota y, which will be square root of x square plus y. Means this will be square root of real part is square of the complex number and square of the imaginary part of the complex number. Square of real part of the complex number plus square of imaginary part of the complex number. In this formula, remember, imaginary part is the number which is in multiplication with iota. Imaginary part is not number with iota itself, right? If I take x plus iota y and I ask what is the imaginary part, it will be x. And what is the real part? It will be x. And what is the imaginary part? It will be y, not iota y. So number with iota is the imaginary part. It's not with iota. If I have complex number z and I want to find out its modulus. So if I have complex number 1 plus iota, what will be its modulus? It will be root of real part square plus imaginary part square, that is root 2. 1 minus iota, real part square plus imaginary part square, again root 2. In case of modulus, plus or minus does not affect the magnitude of modulus because there is square in it. So if you will take minus 1 to the whole square in place of 1, answer will be same. If you have complex number 3, its modulus will be as it is, minus 3. If you have minus 3, it will be 3 because we will write it as square root of real part square plus imaginary part square. So real part square means minus 3 whole square will be 9 and 0 square will be 0. So output will be 3. Understood or any doubt? Okay. Next, let's say what is the relation between conjugate and modulus of a complex number. So we have complex number z which is x plus iota y. Then its conjugate will be x minus iota y. And if you will look at the mode of z, this will be root of x square y square, which will be same as mode of conjugate z. Now, if you multiply z into z conjugate, this will be x plus iota y multiplied with x minus iota y, which will behave as identity a plus b, a minus b, which has to be x square minus y square. But it will be x square plus y square because of iota square. And if you will look at the value of x square plus y square, it can be given as square of mod z or square of z conjugate. So z into z conjugate is same as mod z square plus, mod z square or square of mod of z conjugate. Understood? Or any doubt? Remember, all the algebraic identities are valid for complex numbers also. So if you are having a plus b whole square, same will be true for z1 plus z2 whole square, where z1 and z2 are complex numbers. There are certain basic properties of conjugate and modulus which will be frequently used. One of them is if you are having z1 into z2 mod, this will be same as mod of z1 into mod of z2. If you are having mod of z1 divided by z2, you can distribute mod to individual complex number and you can write it as mod of z1 by mod of z2. If you are having z raised to power n mod, you can interchange mod and power. So you can write it as mod z raised to power n. This is number third. In case of conjugate, z1 plus or minus z2 conjugate can be written as z1 conjugate plus or minus z2 conjugate, which means conjugate can be distributed to all the complex numbers in the operation. If we have z1 multiply z2 conjugate, it will be z1 conjugate multiply z2 conjugate. z1 by z2 conjugate overall will be same as z1 conjugate by z2 conjugate. Same is true in power. If you have z raised to power n and then take its conjugate, it will be same as z conjugate raised to power n. Which means modulus and power can be interchanged. Similarly, conjugate and power also can be interchanged. Understood? Next we have different forms of a complex number. First of them is standard form of a complex number. Standard form is z equals to x plus iota y. Second one is Cartesian form of a complex number z. Cartesian form can be given as x plus iota y as well as x comma y. Then we have polar form of a complex number z. Polar form of complex number z x plus iota y is given by z equals to mod z in bracket cos theta plus iota sin theta, where theta is principal argument of complex number z. Then we have Euler's form of a complex number. Euler's form of a complex number, or we sometimes call it as exponential form of a complex number, which is given as z is equals to mod z e raised to power iota theta. Again, theta here is argument of z. In this expression, e raised to power iota theta is known as Euler's formula, and it is given by cos theta plus iota sin theta. So these are the different forms of a complex number. Next is De Moivre's theorem, which allow us to solve higher power of a complex number. Spell क्या था? Which is, if you have cos theta plus iota sin theta raised to power n, then you can write it as cos n theta plus iota sin n theta, which allow us to solve with higher power of any complex number z, which means it will be mod z e raised to power iota theta raised to power n, which will be mod z raised to power n, which will be iota e raised to power iota n theta according to law of exponent, which will be mod z raised to power n, and cos iota n theta can be e raised to power iota n theta can be written as cos n theta plus iota sin n theta. This is known as De Moivre's theorem. Understood or any doubt? In this concept, n may be any rational number. N may be any rational number. It cannot be irrational. Understood? If you want to find out square root of a complex number, there is a formula which can be directly applied. And the formula is, if z is equals to x plus iota y, and you want to have square root of z, that is square root of x plus iota y, then its answer will be plus or minus square root of mod z plus real part of the complex number divided by 2 plus iota square root of mod z minus x divided by 2. This will be the relation if y is greater than 0. Otherwise, we will have plus or minus square root of mod z plus x by 2 minus iota square root of mod z minus x by 2. This will work if coefficient of iota is less than 0. If you are not able to remember the formula, you can directly check the options. We can go by options also to solve it. Understood or any doubt? So in next lecture, we will do some questions on complex number and concept of argument. Rest of the complex number is completed. In aptitude, we have average, a very simple concept. Concept is very simple. We are given with some data or some observations, and we have to find out the average of those observations. And these observations are discrete, which means individual value will be given to you. So average is given as sum of all the observations divided by a number of observations. We write it as x bar is equals to summation xi divided by n. I starts from 1 to n. In this case, summation xi is the sum of observations and n is the number of observations. This is first point. Second point is, which is about average speed. Let's say this is a certain distance and one part of this distance is covered with x unit velocity, that is x kilometer per hour or x meter per second. And another part of the distance is covered with speed y is equals to y kilometer per hour or y meter per second. And we have to find out average speed of the person. So this is, let's say, kilometer per hour. This is also kilometer per hour. And if the distance covered is equal, let's say this is equal, which means half part is covered with x kilometer per hour and half part is covered with y kilometer per hour. So in that case, what will be the average speed? So average speed will be equals to total distance. Let's say this distance from here to here is z, and this distance is also z unit. So total distance will be 2z divided by time taken. Total distance by total time. Time taken in the first z part will be z by x, and in the next it will be z by y. So if you will simplify it, this will be 2 divided by 1 by x plus 1 by y. And on rearranging, average speed can be given as 2xy divided by x plus 1. Next we have, if a certain journey is split into 3 equal parts. One part is traveled with x kilometer per hour, another part is y kilometer per hour, and the remaining is z kilometer per hour. All the parts are equal. What will be the average speed? So in this case, average speed can be given by, if you will look at here, average speed is 2 upon 1 upon x1 plus 1 upon y1. This is basically the concept of harmonic mean. It implies that equal distances covered with different speeds will be in harmonic progression. Which means if you are having 3 different parts or 3 equal distances, this will be 3 divided by 1 by x plus 1 by y plus 1 by z. Similarly, you can go for 4 equal parts and 5 equal parts. Understood? First question is, find the average of following set of numbers. Numbers are 354, 281, 623, 518, 447, 702, and 876. What will be the average? So to find out the average x bar, we'll have to take summation of all the observations divided by number of observations. This will be 876 plus 354 plus 281 plus 623 plus 518 plus 447 plus 702 divided by number of observations. So these are how many observations? 1, 2, 3, 4, 5, 6, 7. 7 observations total are there. If you will sum it up, if you will add it, it will be 3801 divided by 7, and the final result will be 543. Straightforward question. Second question is, the body weight of the body weight of the body weight of 6 boys is recorded as 54 kg, 64 kg, 75 kg, 67 kg, 45 kg, 91 kg. Find the average weight. Find the average weight. Remember, when you are solving a question for average, the units of the data or units of the observations has to be same. If one of the unit in kg, all the units has to be in kg. If one of the unit in grams, all the units has to be in grams. So average weight will be x bar is equals to summation xi divided by number of all the observations. You can write it as, this will be how much? If you will add 54 plus 64 plus 75 plus 67 plus 45 plus 91 divided by number of observations. It is clearly mentioned that there are 6 boys. So number of observations will be 6. Okay, so how will you solve it? What will be the summation of these quantities? It will be 396 divided by 6. And on simplification, this will give you 66 kg. Understood? Next question is, there are 6 numbers. There are 6 numbers, 30, 72, 53, 68, x and 87, out of which x is unknown. Average of the numbers is 60. Find the value of x. Average of the numbers is 60. Find the value of x. So we know that average of the numbers x bar will be summation xi divided by n. So summation xi can be given as n into x bar, and summation xi will be summation of all the given observations plus x. Yes, this will be summation xi. Summation xi means what? Summation of all the observations. In these observations, some of the observations are given and some of the observation is missing. So we will have summation of all the given observations plus missing observation is equals to n into mean. So missing observation can be found out directly by the formula. Missing observation x will be n into x bar minus summation of given observations. So what will be the answer? N is in this case n is 6 and x bar is 60 minus given observations, summation of given observations will be 30 plus 72 plus 53 plus 68 plus 87. Yes or no? This will be 360 minus, this is complete 310. So missing observation will be 50. Understood? Next question is, find the average of all prime numbers between 30 and 50. So first of all, write down the prime numbers between 30 and 51. The first prime number between 30 and 50 will be 31. After 31, it will be 37. After 37, what will be after 37? 41. After 41, it will be 43 and then 47. These are the prime numbers between 30 and 50. And we have to find out their average. So average will be summation xi divided by number of observations. Summation xi will be 31 plus 37 plus 41 plus 43 plus 47 divided by number of observation, which are 1, 2, 3, 4, 5. Number of observations are 5. So you can find out x bar. What will be the summation of these numbers? Yes, anyone?
Sir, 199.
कितना आया भाई, ऐड करके बताएंगे?
199 by 5.
199 divided by 5, which will give us 39.8. Let's take some important results. Question may be like, find the average of first n natural numbers. First n natural numbers. So average is summation of the observations divided by number of observations. So to find the average of first n natural numbers, we have to find out sum of first n natural numbers. Sum of first n natural numbers, which is given by n into n plus 1 by 2. And number of observations will be 1, n sorry. So x bar will be sum of first n natural numbers, that is n into n plus 1 by 2 divided by total number of observations will be n. So this will cancel out, which implies that average of first n natural numbers will be n plus 1 divided by 2. Now let's say we have to find the average of first 40 natural numbers. So this will be how much? X bar will be n plus 1 divided by 2. N is 40 plus 1 divided by 2. This will be 41 divided by 2, which will be 20.5. Are you getting it? Similarly, you can find the average of square of first n natural numbers. N natural numbers. In that case, you have to find out summation of n natural numbers with power 2, or sum of the square of the natural numbers, that is summation n square. Its standard formula is n into n plus 1 into 2n plus 1 divided by 2. So average will be summation n square divided by number of observations. This is n into n plus 1 into 2n plus 1 divided by 2 into n, and factor will cancel out. So average of average of square of first n natural numbers will be n plus 1 into 2n plus 1 divided by 2. Next is, if you want to find out average of cubes of first n natural numbers. First n natural numbers. In that case, sum of first n natural numbers cube is summation n cube, and it is n into n plus 1 divided by 2 to the whole square, which will be n square into n plus 1 to the whole square divided by 4. So average will be sum of cube of first n natural numbers divided by number of observations, which is n. So this will be n square into n plus 1 to the whole square divided by 4 times n. One of them factor will cancel out. So its average value will be n into n plus 1 to the whole square divided by 4. Any doubt? Next question is, find the average of first 20 multiples of 7. So what are the first 20 multiples of 7? Yes, average will be first 20 multiples of 7 will be, let's look at it at in this way. If we have multiples of 7, 20 multiples of 7, this will be 7 times 1, 7 times 2, 7 times 3, 7 into 4, 7 to 5. These will be the multiples of 7. And we are going to 20 multiples. So we will start from 1 and we will go till 20. So 7 multiples of 20, 20 multiples of 7 will be 7 times 1 plus 2 plus 3 plus dash dash 20 divided by 20. Now this will be 7 in multiplication with 1 plus 2 plus 3 plus dash dash 20 is sum of n natural numbers. And sum of n natural numbers is given by n into n plus 1 by 2. So you can directly apply the formula n into n plus 1 by 2. N is 20. So this will be n into n plus 1 divided by 2 divided by 20. So on rearranging, this will be 7 into 20 into 21 divided by 2 into 20. 20 factor will cancel out. So I will have x bar as 7 1 the 7, 7 to the 14 divided by 2, which will be 2 7 the 14, 2 3 the 6, 2 5 the 10. So x bar will be 73.5. Understood? These are the questions you have to solve with. A man bought 5 shirts at rupees 450 each, 4 trousers at rupees 750 each. And 12 pairs of shoes at rupees 750 each. Harji. What is the average expenditure? Second question is the average of five consecutive numbers. Five consecutive numbers A, comma B, comma C, and D. Five A, comma B, comma C, comma D, and E is 48. What is the product of A and E? What is the product of A and E? Next is the average age of a man and his son is 40 years. The ratio of their ages is 11 is to 5. What is the son age? Next question is of the three numbers, second is twice the first and is also thrice the third. Is also thrice the third. If the average of three numbers is 44, is 44, what is the largest number? अभी तुम लोग क्या करना है, टू डालना है कि खुद से पढ़ना। ये भेजता डाउनलोड करना। तुम्हारे को पढ़ने नहीं आ रहा, पता नहीं चला तुम पढ़ रहे हो। तुम्हें उस वर्ग के साथ साथ शामिल हो गए थे घूमने वाले। ये बार 7 नहीं थी घूमने वाली, इसलिए बैठ गई। तुम पढ़ने वाली थी यहाँ से दिख नहीं रही पढ़ते हुए। क्या बोला ना? मुझे दिखना नीचे पढ़ता हुआ किसी टीचर मेरे पास है, किसी टीचर के पास पढ़ते हुए दिखो। ये नहीं दिखना, ये नहीं होना है कि मतलब पढ़ाई छोड़ दी। एकदम सुबह में मुझे पढ़ेगा, तेरा सिपाही पढ़ता दिखता है मेरे मुझसे। तेरा सिपाही तो हमेशा नजर नीचे करके बैग रखना चाहिए, तब देखना। हाँ? नहीं, अभी तो क्या करना होगा, सेंड कर दो भैया, डाउनलोड करना। हाँ, पुरानी तो अच्छी होती नहीं है, आजकल बहुत खराब करती है। बच्चे को एक ही बना कंटेंट दिया है। तो सरकार ने पढ़ाती है, सही पढ़ाता हूँ। वो बच्चा इतना होशियार निकला, मेरा बुक ले लिया। अभी मैं दे दिया था उसको, उसका मुझे नहीं याद। मोटा सा और मेरा कुछ काम का देखते ही ना होगा। थैंक यू। रोज से एक्सेल कर था। हाँ, एक्सेल में तो फोन करना ज्यादा अप्लाई आगे कर। हाँ, जाना भी जरूरत बैंक नहीं है। वही बुक लाना ही कर छोड़ दिया मैं तो साथ में। नहीं किसी को डाउट है? डाउट है?